Hey there, man, Alejandro, and welcome back for day 203 of me doing the Daily LeetCode challenge that there is 1 year's worth of green contributions here on GitHub. So today's problem is for February 4th, 2025. Without further ado, let's get straight into it. Okay, today we get another LeetCode easy. Problem 1800, maximum ascending subarray sum. Given an array of positive integers nums, return the maximum possible sum of an ascending subarray in nums. Okay, like LeetCode is just on a sorted problem streak. Okay, it's defined as a contiguous sequence of numbers. Is ascending if for all I L less than or equal to wait. A subarray is ascending if for all I where L less than or equal to I less than R. Oh, it's just defining the subarray. Okay, I thought it was like, a number has to be less than or equal to its index and so on. Okay, no, that's not the case. So you just want a sorted subarray. Yeah, strictly increasing. Okay, note that a subarray of size 1 is ascending. Okay. What do we want? Return the maximum possible sum of an ascending subarray. Okay, so here, okay, we literally do what we did yesterday. It's just that we keep track of the sum as we do it. Okay. Okay, let me make sure. Okay, my brightness is as high as possible. I guess the lighting in this room is just not as good. Here we'll just do cur sum is equal to 0. Here we'll do res is equal to 0. Here we'll do prev num is equal to float of negative infinity for num in nums. If we don't even have to keep track of the length. We just need to keep track of the sum. Okay, so instead of count, we do cur sum. But otherwise, it's exactly yesterday's problem, except you only have to worry about ascending and not even descending. Okay, this is literally going to be very, very nice and short. So if num is, so if prev num is less than num, then we're chilling. So in this case, cur sum plus or equal to num. Oh, can the numbers be negative? Oh, no, they can't even be negative. Okay, numbers can't even be negative. Okay. Right, otherwise here I do res equals max of res and cur sum. Oh yeah, so we don't even have to assume, something like this. We don't even have to make it the very first number. Okay, it makes things super nice and convenient. So here we'll say prev num is equal to num. And then continue. Otherwise here we'll say res is equal to max of res comma cur sum. And here cur sum is equal to num. Prev num is equal to num, right? And return max of res comma cur sum. Does this work? Let's see. Let's run it. There we go. Accepted. Let's submit. And there we go. Bada bing, bada boom. We have a 0ms beats 100% solution. That is exactly what we like to see. Okay. Although it doesn't have my streak. Okay, let me just refresh. Okay, there we go. It does have my streak. Okay, very nice. Submissions, yeah, accepted. Okay, now it's going to be like that, so we can just resubmit, not to worry in the world. And there we go, 0ms beats 100% solution. That is exactly what we like to see. Okay, so since I have board game night with my friends, I'll just keep it short here. Plus we have an O-event solution, but yeah, here you could just do if res less than cur sum. You could do res equals cur sum, right? And then here's like, return res. If res larger than res, if res greater than cur sum, else cur sum, right? So that way it's like, you don't have to do max. And for prev num, you could do something like all the numbers are at least 1. So here you could do something like 0. And something like this will work. It'll just be like a little bit faster in terms of the O of 1 time, right? And so we'll still have 0ms. But honestly, you know what? Making it like this, we'll just make it more readable for the explanation. So we'll just keep it as such. And there we go. Bada bing, bada boom. This is still nice and reasonably efficient. And, well, it's all O of n, right? Which is kind of the point. So there we go. We'll keep it as such. So, as always, in all my videos, I do a quick recap of how I was able to solve the problem. So for this one, it's just very simple. You want the maximum possible sum of an ascending subarray in nums, right? And the way that you do this is essentially, you're going to start from the very first number, and you're going to ask myself, okay, is the previous number less than the current number. If that's the case, then it's like, okay, great. We have one more number inside of the current ascending subarray that we're looking at, right? Essentially, we want a strictly increasing subarray. And so we'll just do what we did in yesterday's problem. We'll always like check, okay, is the previous num less than num, right? For every single number in nums. If so, then great. Since all the numbers are positive, we don't even have to worry about negative numbers. We can just keep adding a number to our current sum, representing the current subarray sum, right? Because it's still sorted, because the current number is still greater than prev num. So we'll say, okay, current sum, we're going to add to num, which is a positive number. Here we're going to set prev num to the current num, because that way when we get to the next iteration, this will be the new prev num, and we're just going to continue, right? Otherwise, once we get to a point where it is not the case that the previous number is less than number, then it's like, okay, here ends a streak, right? For example, here, okay, every number is greater than flow to negative infinity, so for the first one is going to be true. Well, here we'll get 10, 20, 30, and then we get to 5, right? 30 is not less than 5, so here what do? We say, okay, we'll grab the sum of this guy, and it might be a new maximal sum, right? So here we'll say res is equal to max of the current result and cur sum, right? And here what we'll say is like, okay, from this point forward, we're now going to reset our array here, right? Because it doesn't matter which left index you do, you're always going to be blocked by this. And since all the numbers are positive, the longer the subarrays, the larger it will be in terms of sum, right? So you only want to consider the larger subarrays. And so here we'll start from here again and keep looking at, like, you know, the new maximal sum, right? Here the sum was 10 plus 30 plus 10 plus 20 plus 30 is 60. Here's 15 plus 50 is 65. So this one would be larger here when we get to it, right? At the very end, we'll return the max of res and cur sum, because res, here this will be the current sum, so res hasn't been updated to that. So at the very end, you got to make sure they return max between res and cur sum, right? But the point is that, like, go from the very start, keep incrementing, like, you know, the length of your current strictly increasing subarray until you get to a point like this where it breaks, in which case it's like, okay, let's grab the current sum that we've built so far. So here it's like, you know, cur sum is initially 0, res is 0, prev num is negative infinity. For each number in nums, you know, as long as it's the case the previous number is less than num, we're still in a sorted array, so add that to our sum and set the prev num valid. And then otherwise, what we're going to say is like, okay, if that's not the case, then we're breaking, right? So whatever current sum is, like, you know, the previous sorted array's, like, you know, current sum. So we'll set res to the max between its current value and that new sum. And then we'll say, okay, we now only have one number, right? So we'll make current sum equal to that number. We'll make prev num equal to that number, like, for example, 5 here, and then we'll move on to the 10, right? Because here we'll just have, you know, a sum of just the number 5, right? In the very, very, very end, we'll just take the max between res and the current last sum, right? So for example, here, whatever is the last increasing subarray, which might be just one element or more, we still haven't, like, baked that into the result yet. So we'll just take max between the current best result we've seen so far and the current sum that we're looking at, right? Which might be the whole array, so on, so who knows, right? But the point is you just keep going increasing, just keep looking at, like, you know, sorted increasing, strictly increasing subarrays, and for each of them, okay, once it breaks, essentially take the sum of the current increasing subarray that you were looking at and just continue with the next one and just keep doing it until you've exhausted all the numbers and nums, and that is pretty much it. So hopefully that solution makes sense. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment. Well, otherwise, I'll catch you next one. So till then, ciao, ciao, my friend. Bye-bye.